What if that box of old batteries in your garage could actually save you hundreds of dollars while also keeping usable energy out of the landfill? Every year, millions of lithium batteries from laptops, power tools, and e-bikes get thrown away in the United States. Most of them still have a lot of life left, but people don't know what to do with them. Meanwhile, buying a proper portable power station can easily cost you $300 to $600 or more. That combination, wasting perfectly good batteries while spending a lot of money on new ones, never made sense to me. I had a box full of old laptop and power tool batteries sitting around for years. Every time I saw it, I felt like I was missing an opportunity. These weren't just trash, they were energy that could be reused. If I could turn them into a working power station, I wouldn't just be saving money, I would also be doing something better for the environment and creating a backup power source I could actually rely on during outages or camping trips. That thought kept coming back until I finally decided to do something about it. I'm not a professional when it comes to electronics. I've done some DIY projects before, but working with lithium batteries always felt risky. Still, after learning more, I realized these batteries can be safe and useful if you handle them the right way. So I made a decision. I wasn't going to throw that box away. I was going to try building a real power station from it. Not just something that works, but something that looks clean and professional, something I could feel proud to own. While thinking about this project, I realized it could give me more than just a power source. It could save me a significant amount of money compared to buying a new one. It could reduce the amount of electronic waste I was contributing to. And more importantly, it could give me a reliable backup power solution that I built myself. Those benefits made the whole idea feel worth pursuing. But here's something important most people don't realize about old lithium batteries. They can still be dangerous if you skip the safety steps. That's why I promised myself from the beginning that I would take it slow, use a proper BMS, and do everything carefully. If I was going to turn trash into something valuable, I wanted to do it safely. So I cleared my workbench and started getting ready to work on that box of batteries. I didn't know yet how many of them would actually work, or what challenges I would face. But I knew this wasn't just about saving money anymore. This was about turning something people throw away into something genuinely useful for my wallet, for the environment, and for peace of mind when I need backup power. After deciding to build this power station, I knew one thing had to come first: safety. Working with old lithium batteries can be risky if you don't protect them properly. That's why I made the battery management system, or BMS, the most important part of this build. A good BMS protects the batteries from overcharging, over-discharging, and short circuits. Without it, even good cells can become dangerous. I wasn't willing to take that chance. Safety was my top priority, so I spent extra time learning exactly how to test the cells and connect the BMS correctly. I started by testing the voltage of each cell with a multimeter. I expected to see around 3.7 volts per cell when fully charged, and around 2.5 to 3 volts when discharged. Any cell reading below 2.5 volts was immediately set aside as bad. I also checked the internal resistance of each cell and discarded any that showed high resistance, which usually means the cell is damaged or worn out. Once I had selected the good cells, I began connecting them to build the battery pack. I first wired them in parallel to increase capacity, then connected them in series to reach the voltage I needed for the inverter. This step required careful attention. I double-checked every wire and connection before proceeding. I even used heat shrink tubing and cable ties to secure everything neatly. While building the pack, I kept thinking about why so many DIY battery projects fail. Most of the time, it's not because the cells are bad, it's because people skip proper protection. I didn't want to be one of those stories, so I took my time and double-checked every connection before moving forward. After the battery pack was complete, I installed the BMS. Installing the BMS correctly was the most important step of the entire build. I followed the manufacturer's instructions for wiring polarity and connection order. I made sure the BMS was placed in a safe, accessible location so I could monitor everything easily. Once everything was connected, I turned the system on. The BMS immediately started monitoring the voltage and temperature. Seeing the BMS light up and begin working gave me a real sense of relief and confidence that the project was now properly protected. But things didn't go perfectly. At one point, I made a wiring mistake that caused the BMS to shut everything down. It was frustrating, but it also proved that the protection system was working. Instead of pushing through and risking damage, I stopped, checked my connections again, and fixed the error. That small failure actually made me more careful for the rest of the build. After correcting the wiring, I turned everything on again. This time, the display lit up. Seeing the battery percentage appear on the screen for the first time felt like a real milestone. It wasn't just a pile of batteries and wires anymore. It was starting to look and feel like an actual power station. At that moment, I realized something important. Building something like this isn't just about the final result. It's also about learning to respect the process and the risks involved. Rushing would have been easy, but taking the time to do it safely felt much more rewarding. With the core system now working, I started thinking about the next step. So far, everything was functional, but it still looked rough. The real challenge was ahead, turning this working power station into something that actually looked good. With the core system now working, I started thinking about the next step. So far, everything was functional, but it still looked rough. The real challenge was ahead, turning this working power station into something that actually looked good. I had spent a lot of time building the battery pack, the BMS, and the inverter. But no matter how good the electronics were, if the outside looked messy, it would never look like a professional product. That realization hit me hard. I didn't want to end up with something that looked like a science fair project. I wanted it to look clean, sleek, and professional, like something you would see on a store shelf next to Jackery or EcoFlow units. This is where the transformation really began. I started by designing a simple enclosure that would protect everything while still looking modern. I bought a clean plastic case and cut out holes for the ports. I also planned to add a lid so I could open it whenever I needed to check the BMS or batteries. The goal was simple but important: make the whole thing look finished. While working on the case, I ran into my first real challenge. The power buttons on the inverter didn't line up perfectly with the holes I had cut. I had to redo the layout 3 times before I got it right. This small problem taught me an important lesson. Even professional-looking builds can have small design issues, and you have to be flexible. Once the case was ready, I moved on to the most satisfying part: making it beautiful. I added a nice digital display that showed battery percentage and voltage in large, easy-to-read numbers. I also added a set of LEDs around the edge of the case that would light up when the battery was charging or discharging. For the output ports, I chose a combination of USB-C, USB-A, and a standard AC outlet. I wanted people to feel like they were looking at a premium product. I also added a few small touches that made a huge difference. I used high-quality connectors so everything looked clean and professional. I hid all the wires inside the case and used cable management to keep everything neat. I even painted the outside a simple matte black to give it a more premium feel. It wasn't all smooth sailing. I spent 2 full evenings on the enclosure alone, and I made mistakes along the way. I almost screwed up the placement of the AC outlet. I had to take it all apart and start over. But every time I hit a problem, I reminded myself that this was the part that would make or break the entire project. If it looked good, people would be more likely to trust the product. By the end of this phase, I could finally see the power station taking shape. The rough electronics were still there underneath, but the outside now looked completely different. It wasn't just functional anymore. It looked like a real, ready-to-use power station. This was the moment I felt proud of the work I had done. I wasn't just building a battery pack anymore. I was creating something that could actually stand on its own as a finished product. Now came the moment of truth. Would this thing actually work, or was all this effort for nothing? Now came the moment of truth. I powered everything on and watched as the display lit up for the first time. The battery percentage jumped to 98%. It was working. The BMS was monitoring everything perfectly. The inverter was responding instantly, and the LEDs glowed bright. This was the first time I had seen the entire system come alive, and it felt incredible. I didn't stop there. I tested it with a real load. I plugged in a small fan and a laptop charger, then turned the power station on. The fan started spinning smoothly, and the laptop charger began charging without any problems. The display showed the battery level dropping slowly and steadily. I ran the test for almost an hour. It never overheated. The BMS stayed cool, and the voltage stayed stable. The whole thing felt professional and reliable. I also did a quick test with a power tool. I connected a circular saw and let it run for a few minutes. The power station handled it without any issues, and the display showed the battery percentage dropping at a reasonable rate. This proved that the station wasn't just a toy. It could actually power real tools when needed. Here's the big picture. From a dirty box of junk batteries to a clean, professional-looking power station that actually works. And the best part? It didn't cost me hundreds of dollars like the ones in the store. This project taught me a few important lessons I'll never forget. First, safety always comes first. No matter how cool the build looks, if you don't protect your batteries properly, you're risking fire or damage. I learned that the hard way, and I'm glad I took the time to do it correctly. Second, the transformation doesn't have to be perfect to be valuable. The inside can be messy, but if the outside looks good and the system works, people will still trust it. Third, turning trash into something useful is more rewarding than just saving money. It's about doing something good for the environment and feeling proud of your work. If you have old batteries lying around, don't throw them away just yet. With the right steps and a little patience, you can turn them into something genuinely useful, something you can be proud of, something that saves you money, and something that helps the planet. That's exactly what I learned from this build. Thanks for watching. I hope this project gave you some inspiration to turn your own junk into something useful. If you try it yourself, I'd love to hear how it goes. Drop a comment below.